we're going to make a gear, and that's going to help us get ready for creating a spirograph. I've provided 2 links for creating the gears. One shows us some of the information about spur gears, and we've got some great pictures here. This comes from Boston Gear Engineering, and we've got center to center distance. We'll definitely be working with a pitch circle, and a lot of different nomenclatures provided here. The spur gear comes from the involute form, which makes the gear tooth. We'll use that. We'll base ours off of a diametral pitch and a 14.5 degree pressure angle. Oh, and a lot of the equations are shown down here and the spur gear formulas. The path that I'm taking to build my gear was provided by Beyond Mech a long time ago. So here's my starting set of equations and parameters. So that's where I'm going to start from, but I'm going to take it from there and kind of go forward on my own. So the first thing in my CAD model, I'm going to take these starting parameters, give them a copy, and go start my file. Alright, I've changed my ribbon around here so I've got access to these a little better, but in my relations, I'll paste in those options, hit the check mark so that they're added as parameters, but I can't modify them this way, so now I can delete those and they'll stick around. Next I need to go get the dimensions. Alright, so the inputs are still given here, and now we have a lot of other stuff that's being calculated. I like to give credit where credit is due. We'll copy and paste. A few reworks are needed. So the first issue I have with this setup is that the diametral pitch is calculated based on the pitch diameter, but really the diametral pitch needs to be an input. So we need to rewrite this equation and instead have the pitch diameter calculated based on the number of teeth divided by the diametral pitch. I'm going to do a lot of copying and pasting because all of the relations here are dependent on spelling. Okay. The other thing I need to calculate, so now we've got the number of teeth is an input of 11, pressure angles input 14.5, width is pressure, input is 1, diametral pitch is 4, that's all great. But we also have the outer diameter as an input, which it really needs to be calculated. So the outer diameter is the pitch diameter plus 2 times the addendum. So we're going to add that equation in. Pitch diameter plus 2 times the addendum. Okay. Alright, so there's the addendum. So we're going to say that the outer diameter equals pitch diameter plus 2 times the addendum. So I'm adding this in after the addendum was calculated. But here's a quick little thing that we notice is that the root diameter uses the outer diameter, so that has to be relocated to after the outer diameter was calculated. Okay. And that should be good. We've got 4 inputs, and that's how we'd select our gear, and that's great. Let's move on. I'm going to start by sketching 4 circles on the front plane. So So we know that outer diameter was calculated to have a diameter of 3 1/4, so I'll make that 3 1/4. And that resizes my screen so I can make a few more sketches. I could do these all as a single sketch, but it's easier for me to know which one's which this way, and you'll see that. Okay. All right, so my first sketch, I'll make that my pitch diameter because that's pretty important. The second one, I'll make the outer diameter. Third one is called the base diameter, and the fourth one is the root diameter. All right, so let's shift that over, bring in our relations, and add some set some circle dimensions. Okay, so the first one's the pitch diameter. Well, that's way out there. So D0 equals pitch diameter. D1 equals outer diameter. Oops. D2 equals base diameter. D3 equals root diameter. And good. All right, so that root diameter we're going to extrude. And back into the relations, that depth is going to equal the width. Perfect. Okay, next we need our tooth geometry. So for the tooth geometry, we got to do a little bit of setup. We're going to start by creating a coordinate system on the front face. It is going to we're going to drag these onto our planes as references, and instead of offset, we align them. Orientation looks good. I like X coming to the side, Y up, Z out, that's all good. For the properties, CS0 is fine with me for a name. Alright, the next thing we're going to do is add a curve from an equation. So that we need to select a coordinate system to start our equation, and from the equation box we're going to add some equations. Those are provided on the How to Model Spur Gears. Before I've gone through all this stuff. Alright, and here's our equations. Copy and paste. And essentially we're going to be calculating out some X and Y locations at different times. And as we go from 0 to 1, so those are T steps from 0 to 1. And there's our involute tooth profile. So that's one side. We need to flip it over and get the other side. So we're going to do a couple of helper geometries to get us there. Create a datum point at the intersection of the curve, and by holding down Control, the pitch diameter. Okay. So the pitch diameter is going to be the second one in from the outside, not the base diameter where the curve starts, but it's going to be just a little bit above that top plane. So holding down Control, point 0 intersects the equation curve and the pitch diameter. Next, we're going to create a datum plane that goes through that point and also goes through the center point, center axis of the root. So we've got a datum plane that's going from the pitch diameter of the curve through the axis. The trick here is the pitch diameter, where this point is located, is going to be where your tooths make contact. So we're going to make another datum plane that's going to show the mirror plane for the gear tooth. So we're going to go from datum 1 and the axis, and we're going to have an angled plane through the center line, offset from the datum that we made. Okay. All right. So the angle to this plane is going to equal this angle here is going to equal 360 degrees divided by the number of teeth divided by 4. So that means that for each tooth, there's actually a tooth and a gap. So that gap has one half the tooth, the second half the tooth, one half the gap, and the second half the gap. So 360 divided by the number of teeth divided by 4. Control G regenerates, and we'll mirror the curve over that plane. All right. Create a sketch on the front. All right. We're going to use a lot of this geometry. So I'm going to project both of the curves, the outer diameter, and the root. I'm going to get a straight line in here, and this straight line is going to be tangent to the curve and straight out. Okay. Had a line down here from the base. Again, we're looking for tangent to the curve to the base. Use my corner tool to clean all this up, clicking inside the tooth geometry. We got a beautiful looking tooth there, and we'll extrude that to the base. You could also extrude it a depth of width. All right, I'm going to take all of that geometry, the coordinate system, the curve, the points, all of that stuff. I'm going to highlight all of it and group it, and I'm going to call that the tooth. All right, take that tooth, give it a pattern. Okay. We'll make that an axial pattern around the center axis, and we're going to have 11 teeth filling up the full 360 degrees. Something doesn't look right there. Let me cancel and try that again. I know why. It's the extrude I wanted pattern. All right. Axial pattern around the center line. 11 of them. Fill up 360. There we go. I guess we should rename this teeth. All right. I can turn off the line and the axes, but these sketches are going to kind of stick around here. Let's hide those. Same thing with the curves. And on the View tab, I'm going to save that status so they don't keep showing up. All right, relations. One more thing to do here. Let's set the number of teeth. I'm going to pick the smaller value, and that's going to equal number of teeth. Alright, time to check the pattern, make sure everything works. Let's set the number of teeth to 20. Control G. Looking good. I also want to change the diametral pitch to 20. Okay. Perfect. Let's try a little bit bigger. And at some point this might break, and that's because the root diameter and the base diameter flip, but we're looking pretty good here. Alright, let's go ahead and add a family table. Again, family table usually lives in the model intent dropdown. Alright, so we're going to add in some parameters. We're going to include the number of teeth. We might want to be able to change the pitch diameter as well. Oh, not the pitch diameter, the diametral pitch, or the width. We might want to change those. Number of teeth being the largest addition. Alright, so if I have a number of teeth of 12, if I leave stars, everything stays the same. I might want to call this a 12 tooth. 15 tooth, set the number of teeth to 15. And for my purposes, I'm going to have a number of diametral pitch of 20 because that's what we're going to use later on. Okay, let's see how that works. Click the preview. Looks good. Alright, and I think we got it.